Hello and welcome back to Josh Does Math. Today we're going to be finding a general formula for the nth derivative of this function right here. So a good way to do this is usually just to pick up on patterns after you take the first couple derivatives of it. So we'll take the first derivative of this and then we'll take a couple more until we can get a pattern that we can write out using just general x and n. So here's our derivative right here, and I'm just going to use the quotient rule here. So derivative of the top times bottom, well, that's 0, minus derivative of the bottom, that's going to be -1, times top, which is just 1, all over bottom squared. So this is just going to be 1 over 1 minus x squared. So that's what we get. And you could think of this as our 0th derivative. This is just the original function here. So compare the two of them. What do you notice? Well, this is just the same thing except for squared, right? We could view this 1 as being squared also. So far that's what I noticed. We're just squaring whatever the last thing was, which is the original function. All right, well, how about our second derivative? See if the pattern is the same or if it changes at all. Okay, derivative of the top, 0, times bottom, well, it's still 0, minus derivative of the bottom, that's going to be using the power rule. Pull the power out front, 1 smaller on the power, times derivative of the inside, -1, all times the top, all over bottom squared. And this simplifies to, this is going to be 2 times 1 minus x all over 1 minus x to the 4th. So that's just 2 all over 1 minus x to the 3rd power. So that's what we get. So what do we notice? Well, now the power in the bottom right here is just 1 bigger than what it was last time. Also, we now have a 2 in the numerator. So not too sure about that pattern yet, but in the bottom I can see that it's just getting bigger by 1 each time, it seems, the power that is. However, in the numerator we have 1, 1, 2, so maybe we need one more derivative to be able to tell what's going on. So now looking at the derivative of this, so first of all, we'll pull the 2 out front, then we're going to use the quotient rule. Derivative of the top times bottom, minus derivative of the bottom. So that's derivative of the outside times derivative of the inside, all times the top, which our top is actually 1 because I pulled the 2 outside, all over bottom squared. So that's 1 minus x to the 6th power. So we can simplify this a little bit. 3 times 1 minus x squared all over 1 minus x to the 6th. And we can write this as 6 over 1 minus x to the 4th. So now we can kind of see a pattern emerging. In the denominator, yes, we continue to raise the power by 1. So let's just handle that part of it for now. So the nth derivative is going to be something all over 1 minus x to what power? It's going to be 1 minus x all to the power of n plus 1. Because as you can see for the second derivative, for example, it's to the 3rd power. But for the third derivative, it is to the 4th power. So it's always to 1 bigger than whatever n is. So that's why I said to the n plus 1 power. What about the numerator? Well, let's look at our first derivative when n is 1. We get 1. When n is 2, well, we get 2. However, when n is 3, we get 6. And if you'll notice, 6 is just 2 times 3. And as a matter of fact, it's actually 1 times 2 times 3. And 2, you could write that as 1 times 2. And if we were to continue going and taking higher derivatives, you would notice that whatever is in the numerator, like for the fourth one, whenever we take the fourth derivative, in the numerator we would end up with 1 times 2 times 3 times 4. So it would end up being 24 in the numerator. And you can see this pattern that's emerging: 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4. That's just the factorial function, where it multiplies 1 by every integer up until whatever the number is n. So for the third one, we multiplied 1 by 2 by 3 in the numerator. For the second one, we multiplied 1 by 2. So in the numerator, we have the factorial function. In the denominator, we have this power function down here. So this is a formula for the nth derivative of this specific function right here. So it doesn't work for every function, but if this is your function, this is an equation that allows you to find the nth derivative. Thanks for watching.